Okay, for parallel circuit worksheet one, problem one, let's see if we can work this one together. I tend to like to label everything, so I'm going to do that here. At least what they give it to me, what they've given me, and I do that because I think it helps visualize what's going on. So we know we got 12 volts. We don't know the current, and then we've got 4 ohms and 4 ohms. Now, when we have a parallel circuit and resistances that are the same, we can divide it by that number of branches. And that's kind of the easy method of solving these. However, I tend to like to work these through using the parallel resistance formula. And so the very first thing on this one when I look at it that I'm going to have to figure out, right, is that I need to know what the resistance total is so that I can determine the current that's flowing out through this guy and then back to this circuit. So to do that on here, I have voltage and resistance, right? But I need to figure out the resistance total. So typically on here, what we try to do, sorry, I moved the screen a little bit. I'm going to write this out. 1 over RT is equal to 1 over 4 plus 1 over 4. So 1 over RT is equal to 0.25 plus 0.25, right? And then I need to get the reciprocal of this. So this ends up being RT is equal to 1. And if I add the 0.25 and 0.25, I end up with 0.50. And that goes into 1, 2. So my total resistance in this circuit, the equivalent resistance, is 2 ohms. Once I know this, I can now solve for the voltage in here. I'm sorry, the current. So current in the circuit is equal to voltage divided by resistance. So we've got 12. We divide that by 2. So current is 6 what? 6 amps. So over here, this would be 6 amps. And what you can do to kind of stress test this or verify that your answer is right is you can plug these numbers in. So for example, let's say I wrote a different formula over here. Say I wrote voltage is equal to resistance times current. If I did that, my resistance up here was 2 and my current was 6, which means that E would be equal to 12. 12 what? 12 volts. So that kind of proves, if I can plug those numbers in, that the equation is sound, and I've kind of proven it. So that kind of wraps up question 1. Okay, for this problem here, again, I like to label things. It's just kind of how I do it. So I'm with my 12 volts here so that I got kind of an image going. Then I've got current here, 4 amps, which means I got 4 amps coming back. And then looks like we've got R1 and R2, and R1 is 6 ohms. Okay, so step 1 for solving this is going to be finding the total resistance, or RT. So we're going to use Ohm's law, which will look like this. RT is equal to our voltage total over our current total So in this case, we have 12 divided by 4, which means that our resistance total for this is 3 ohms. Step 2 will require that we apply the parallel resistance formula, which, as you might recall, is 1 over RT, which is equal to 1 over R1 plus 1 over R2. So we're going to substitute our known values. So in this case, we know we got 1 over 3. And then here we have 1 over 6. And we don't know R2 in this case. So now we need to solve for R2, which will be step 3. And in this case, what I'd like to do is I'm going to isolate or get the 1 over R2 by itself. So I want to subtract the 1/6 from each side here, which will end up leaving me with 1/3 minus 1/6 is equal to 1 over R2. I like to kind of get my equation set up so that the unknown is in front. So I'm just going to transfer these around. It's the same formula. Now I need to find a common denominator, right, that each of these will go into. So what numbers will 3 and 6 both go into? Well, yeah, they'll both go into 6. So in order to do that, turn that into 6. How many times it goes in 2? 2 times 1 up top is going to give me 2/6 minus 1/6, right? Just like this. And then I'm going to move this a little bit. From there, now we should be able to isolate this down to 1 over R2 is equal to 1 over 6. And then, of course, we've got a denominator underneath the 1, so we can do the reciprocal of this, which would look something like this. And, of course, 1 will go into anything, which leaves us with R2 is equal to 6. 6 what? 6 ohms. Okay. So now I can put that up here. Sorry, a little too big. We could write that in here. Sorry, I'm trying to get this the right size for you. So 6 ohms right here. And again, we could substitute those values in and double check our work, but that should work out in this case. Okay, let's take a look at this problem here. So again, I like to mark what's going on here. We know the voltage, we don't know the current in this case for this one. We know R1 here is 12 ohms and R2 is 12 ohms, like so. So this one, we need to figure out our resistance total so that we can figure out the current that's flowing through this circuit. So step 1, as you might recall, was a matter of determining resistance total. So we'll do that real quick. So it's 1 over RT equal to 1 over R1 plus 1 over R2. Substitute in our values that we do know. We know that R1 was 12. We know that R2 was 12, which will give us, we don't have to change anything with the denominators. We got 2 over 12. 1 over RT is equal to, I'm going to reduce this to 1/6, and then we'll do the inverse of both of these, the reciprocal, which leaves us with, oh geez, I completely botched that R up there. RT is equal to 6 ohms. So now once we know what the total resistance is, or the resistance total, or equivalency for this circuit, we can now solve for the current, right? And since we don't know what the current was, that would be I is equal to voltage over resistance. And our voltage we know is 12. Our resistance equivalency was 6. So our current in this case, total, I should have labeled that correctly, is going to be what? 2 what? 2 amps. So then over here we can write in 2 amps. And if we want to double check our work, again, we could substitute that in here. Maybe, for example, if I wanted to solve for voltage, just to verify, voltage would be amps times resistance. So voltage would be equal to 2, and our resistance, equivalent resistance was 6. So voltage is equal to 12, and that just kind of verifies I got the same outcome is what we first determined there. So let's take a look at the next one. Okay, with this circuit, again, we've got something similar. We got 3 branches in this case. Again, as we've done past, I'm going to just label what I know here. And we don't know the current on this one. R1 is 4 ohms. R2 is 4 ohms, and R3 is 2 ohms. Okay, so the first thing we're going to do here, again, we're going to try to figure out what the total equivalent resistance is so we can apply Ohm's law. So you might recall 1 over RT is equal to 1 over R1, 1 over R2, and 1 over R3. So we're going to plug in what we do know here. We know all of our resistors. So we got 1 over 4 plus 1 over 4 plus 1 over 2. Looking at these, we try to figure out what's a common denominator that these all go into. Probably, you guessed it, they all go into 4, so we don't have to change anything here. And then this one, if we change it to 4, goes in twice. That'll be 2/4 here. 1 over RT is now going to be equal to 1, 2, look at 4 over 4, right? And 1 over RT is going to equal to 1. And then the reciprocal of this would just leave us with RT is equal to 1 ohm. So the total circuit resistance is 1 ohm. And you might also remember that according to the laws for parallel circuits, the total resistance has to be less than any one branch, and we've done that here. So now let's go ahead and we will solve for current now that we know that. So our current total is equal to voltage over RT. Oh, we've got 12 divided by 1, which makes this real easy. Got 12 amps, right? So over here, this would be 12 amps, and then flowing this way, 12 amps, and coming back around this side, 12 amps, right? Sorry, the writing's a little poor there. And then again, I always like to just double check my work. So what I might do in this case, again, I don't know, I usually go after voltage. So voltage is equal to current divided by resistance. And so I'll put this in here, and my current is 12, and my resistance total was 12. I'm sorry, resistance total was 1. My mistake, 1. So voltage again equals 12. So this one makes sense. All right, so let's take a look at this one. In this case, we're trying to solve for voltage. So again, I just like to label some things. Give me a visual, so I'm going to put in here that we've got 12 amps. And let's see here, coming back on this side, we got 12 amps. And then our resistors, so R1 is 2 ohms, and R2 is 4 ohms, and R3 is 4 ohms. Okay, so I'm going to do, so we need to solve, so we're going to have to figure out the resistance total here, and then we can use Ohm's law again. So 1 over T. You're starting to see a pattern here, I hope, with these. We got 3 branches, so substitute in what we know. Look at this. Very similar to the last one, isn't it? So again, we know everything will go into 4, so this becomes 2 over 2. I'm sorry, 2 over 4 plus 1 over 4 plus 1 over 4, which ends up being 1 over RT is equal to 4 over 4. Or the reciprocal of this becomes 1 ohm. So we know now we got 1 ohm. So now to solve for the voltage, right? Voltage is equal to our current total times our resistance total. So here we have 12 amps, and we have a resistance of 1, which means that our voltage in this case is 12 volts. So here we got 12 volts, and then just because I like to double check everything, let's solve for whatever, I don't know, let's solve for amperage and see what happens. So amperage is equal to voltage over resistance. So we've got 12 divided by resistance total was 1. So our amperage ends up being what? 12 amps. And if you take a look, that matches what we had here. So that is good. Okay, so let's take a look at this one here. We've got, again, I just label everything. We get 12 volts. I just find that labeling things, it tends to like just keep it visually so that you're following along, don't make any mistakes. But that's me. So I put this in here. Our amps in this case, we know, right, going this way, we got 12. In this case, we got 12 coming back, right? And then R1, we have 4 ohms. And R2 we don't know, and R3 we've got 2 ohms. You might recall, I think that was the first problem we did. All right, so we're going to figure out our resistance total here. So resistance total is equal to our voltage over our current total. So resistance total in this case, actually we can just work across, make it easier, is equal to 12 over 12 or 1 ohm, right? So now we know our resistance total is 1 ohm. So based on that, we can now use our parallel formula that looks like this. And this was 1 over 1. Remember, we just solved for that up top. And then for R1, we got 1 over 4, 1 over R2, we don't know, and then 1 over 2 here, right? So ultimately what we want to do is get everything kind of lined up. So what I would want to do in this case is to subtract the quarter and the half from this side, right? So I'm going to subtract 1/4, and I'm going to subtract 1/2, and I've got to do the same thing on this side. I'd have to subtract 1/4 and 1/2, which would leave me with 1/1, which was right here, minus 1/4 minus 1/2, those coming from right here, right? And that would be equal to 1/R2. And then I like to keep things with the unknowns, so we're just going to flip these. 1/1 minus 1/4 minus 1/2. And then yes, we got to get the same denominator, so 1/2 equals 4/4 minus 1/4 minus, mistake there, this has got to be a 4, and that goes in 2, so like this. So that becomes 1/R2 is equal, 4 minus 1 is 3, 3 minus 2 is 1, so that's 1/4. Then we do the reciprocal action of this, so R2/1 is equal to 4/1, so R2 is equal to 4 ohms. So up here we're going to put 4 ohms, like so. And then from there, I like to just double check my work again, right? Just trying to make sure I'm thorough so I don't make a mistake, and I make mistakes like anyone else. So let's, again, let's do voltage is equal to amps times resistance, for example, right? And in this case, voltage is equal to here, our amperage is 12, and our total resistance that we solved for in the beginning was right here, was 1. So voltage is equal to 12 volts, and that matches what we have up there. So this is good as well. All right, hopefully that was helpful.